example 2 is going the other direction, like how do we take a mathematical equation like this and put it into words using absolute value. If we model it right directly from the example 1, the way we would word this is that for example 1, the values that are 3 away from 0 is modeling it directly from that. If we are going to use the definition of absolute value, which has the words distance in it, another way we could word it is that it's the distance x is from 0 is 3, or we could say, in other words, let me try and find a good color here. X is 3 away from 0. That's another way we could do it. I want you to pause and try and write B and C as a sentence in words for each of these. Just keep in mind here the distance from is dependent on what's inside the absolute value. What would make that absolute value 0? That's where we're taking the distance from. So pause the video, try for these two. If you make a mistake, listen, it's okay. You can erase and fix it, but you got to give it a shot on your own first, and then we'll talk. I'll erase the covers here. Look at that for both of them. Or if we want to do it the third way, x is 3 away from 2, or in this case, x is 5 away from -4. So it's like taking the first two sentences and putting it into one. Now, I'm not sure if you learned this in Algebra 1, but the algebraic method of solving for an absolute value equation, this here is a conceptual one. So we're going to take that idea and show you how to solve these conceptually, but also algebraically, because we are in an algebra class. So let's start with the algebraic method, and then we'll solve it conceptually afterwards. On a test, if it doesn't specify, we don't mind whichever way you want to solve it is fine, but you got to follow the directions. If it specifically says algebraically, this is the way you have to show it. You have to keep in mind what it means to have an absolute value. It means algebraically inside, or numerically inside here, this value inside here can both be 14 to make the statement true, but it could also be -14 to make the statement true. So in this particular case, I could have the positive version and the negative version of whatever can be inside of there to make the statement true. So x minus 3 could be +14, or if x minus 3 was also equal to -14, it would still make the statement true, because we would get -14 inside the absolute value. The absolute value of -14 is still equal to 14. So in this particular case, we would just solve. X is equal to, add 3 to both sides, we get 17. And for the other one, add 3 to both sides, we get -11. If I was to check each of these, you always, by the way, when you check any algebraic solution, you always substitute it into the original equation. So in this case, I would substitute in 17 minus 3 is equal to 14. Oh yeah, I get the absolute value of 14. And the absolute value of 14 is 14. So this one works. And if I was to check the other one, x, whoops, not x, it's 11, -11. -11 minus 3 is equal to, absolute value of that is equal to 14. That's negative, absolute value of -14 is equal to 14. Oh yeah, the absolute value of -14 is +14. So this also works. So that means both of these two solutions work. So using proper notation, x such that x is equal to -11 and 17. And order doesn't matter here. You could write 17 and then -11. It doesn't really matter. I tend to do them in numeric order, but like the smallest to highest, but that's just a style thing. Now, if I was to do this conceptually, based on what we just learned in example 1 and 2, you can base it on the meaning. So this means up here. Now, you don't have to write it out in words every time, but we just need to keep in mind that this actually means values 14 away from 3. That's actually in words what it means. So if I was to graph this, we want to be 14 away in each direction from 3. So 14 away on the left, 3 minus 14 is negative 11. And on the right, 3 plus 14 is 17. Look, you get the same answer. Oh, look, x such that x is equal to negative 11 and 17. So when it's a simple absolute value, a lot of people can actually do them in their heads. Like if you read it out, like if you think out the meaning of it, a lot of people are like, ooh, this means 14 away from 3. Which values are 14 away from 3? In either direction, it's going to be negative 11 and positive 17. So they don't have to write it all out. Now, you can see algebraically it works out. You can also see if I drew the graph of it, it works out. I want you to pause the video and solve B and C algebraically, and then I will show you how to do them conceptually. We have to fix a few things. If you're going to do it conceptually, you need the term inside the absolute value to have a leading coefficient of 1, but it's definitely fixable, so we're going to do that, or positive or negative 1, I should say. But we can fix that at the end. There's a way to do it conceptually to make life easier for you. All right, so try them algebraically and see if you get the right answer. Pause the video now, and then I'll reveal the answers. Here's B, and here's C. Hopefully you got those two answers. I'm going to show you how to do them conceptually. Now, the problem when you have this conceptually, you want the leading coefficient to be either positive or negative 1 inside the absolute value. So what I need to do first is divide both sides by 2, and you can do that with absolute value as long as you're dividing by a positive 2. So in this case, I end up with the absolute value of, and 2 goes into everything. X minus 4 is equal to 6. And now we just have to remember we want to be 6 away from 4. 6 away from 4 on this side is negative 2, and on the positive side is 10. Did we get negative 2? And wait, what did I do wrong? Oh, I just copied it wrong. I'm sorry. Look, it's 10. I put 12 for some reason here. Whoops. There we go. So I did do it right. Here we get x such that x is equal to negative 2 and 10. I don't know why I wrote 12 up there, but I definitely did it right. So look, you get negative 2 and 10. And then you could do the same for this one. You just need the leading coefficient here. So let me change colors. 4 minus 3x is equal to 18. The problem is right here. This needs to be a negative 1 in this case. So, okay, I need to divide both sides by negative 3. Not negative 3, positive 3. Okay. You can only divide by a positive. Positive 3. Whoopsies. I'm on a roll today. So we get 4/3 minus x is equal to 6. Now, we center this at what would make the inside of the absolute value equal to 0 is centered at, if I substitute it in a 4/3, it would make it 0 in there. So it's centered at 4/3, and then I'm going to add and subtract 6, which is 18/3. So 4 minus 18/3 is negative 14/3, and 4 plus 18/3 is 22/3. Oh, look, same answers as we got up there. So therefore, we have x such that x is equal to negative 14/3 and 22/3.